Good morning, everybody. My name is Harvey Fong. I'm from BioWare. And today's talk describes a workflow innovation I created that allows you to go from the drawing board to the playable prototype with the push of a button. So the goal of this talk is not to sell you a product, because I can't. It's an internal EA-only tool, but they've allowed me to share with you all my working knowledge. So I'm going to be hopefully inspiring you to create something similar at your studios and take on some of these lightweight prototyping ideas. So this is the agenda for today. And I'll refer back to this slide so that you get a sense of where we are in the map. And to introduce Levelshop, I have some quotes from users of the tool. The first quote is from Thomas Vu, lead producer on Darkspore. They've been using it for about a year and a half now, and they're very happy. They're going to be shipping sometime this month. And every single level was prototyped and play tested in Levelshop. The second quote is from Stephen Douglas, and he's a prolific user of Levelshop, and we're going to see several of his drawings later in the talk. So the video I'm about to show you is very important. It's the reason why I'm here at GDC. I did some initial R&D work, and I was able to create this video and show it to my managers. And from there, I convinced them to give me some more time to actually create an actual working workflow. And so this video has a couple rough edges because it's a bit older, but it has the heart of the Levelshop workflow. So what you're seeing here is Inkscape. Inkscape is an open source illustration program very similar to Adobe Illustrator. And so I grabbed it, and I'm not sure if you know, but I'm a technical artist who's partially a programmer. And so being able to take some of the software and just off the shelf and use it is something I can easily pick up on. So I drew a couple shapes, and I just unveiled the layers that I drew them on. And I'd like to think of Levelshop as a word processor for level design. And I might have taken it a little bit too far, because there's a bit of chaos here with all the words that I'm writing, like door and window and stair. And you'll notice that later on, the latest iteration of Levelshop has a much more cleaner interface for those types of things. Now we save the job, or save the file out, and it's an SVG file, structured vector graphics file, which is an XML file. And we do some parsing in Python, and we use Houdini, which is a fantastic 3D package on par with Maya and Softimage. And it outputs a game-ready file here that we load into Unreal. And we're running at double speed just because it's a really large level. And where we wrote stair, we have a ramp with a hole in the ceiling, and where we wrote window, we have a round portal. And you'll notice textures on the floor, on the ceiling, on the walls. And so my drawing board time was about an hour, and my 3D construction was about 10 minutes, and it's much improved these days. And so what Levelshop does then is go from drawing board to prototype. So I have a 2D floor plan of the Starship Enterprise. It's not even a really good floor plan because it has no elevators, and who knows where the medical bay is. And but I've been able to do it very quickly. I did it in about an hour. So that's a very important thing to do when you're at the drawing board phase. And I feed it to the Levelshop machine, and it creates, and it machines out a prototype ready to run. And that's what I did. I loaded up into Unreal and ran around and realized that not having any elevators is a horrible design flaw. You should definitely put those in. And that informs me that I should go back to the drawing board. So this whole drawing board to prototype workflow is a time-honored tradition and used in many industries. So if you're an automobile designer, you'll be creating dozens of design sketches with where you're testing out curves and colors. And at some point, you might take one of your design sketches and mill it out into a scale model. You can make sure your aesthetics are correct, and make sure there's no design flaws before you go into production. If we imagine where Steve Wozniak designing the Apple I, he might have drawn some circuit diagrams on a whiteboard, or maybe back then it was a chalkboard. And he'd be testing out various chips and permutations to see whether he can get better performance or reduce the cost of his chip count. And at some point, he might make a prototype, and that would mean something like a breadboard with the actual chips, where he could determine if the logic that designed in the circuit diagram works in the real world before he manufactures 500 Apple I motherboards. If you're an architect, you'll be making various blueprints of your building layout. But you might decide to make a maquette because there's some things that you can't evaluate at the drawing board stage. If the sun shines from a particular direction, what do the shadows look like? If you look out the window, do these towers block your view? So the prototype is a great place to evaluate your design decisions. And the drawing board is a fantastic place to just get your ideas out of your mind and onto paper. So what does Levelshop add to this time-honored tradition? Well, it takes the drawing board phase, which is a very fast way of getting ideas onto paper, and the prototype phase, and it merges them into the same step. So basically, you draw a floor plan that uses the same amount of energy as those other drawing board methods, the design sketch or the circuit diagram or the blueprint. And you feed it to the Levelshop robot. And the robot spits out a fully playable mesh where you can determine if your design decisions were correct. You can see whether this combat area is large enough, or climbing over this ledge is that's the right distance, or this incline for this ramp is what you want before you go into production. So this is what Levelshop does. But why? So Dale Dowd on Darkspore gives me a quote that helps me explain why. I'm not going to read the whole quote. I just highlighted a section of it. Does the moment-to-moment layout guide me to the end? So that's like level designer speak if I've ever heard it. And that's like a zone where he's strategizing about gameplay. That's the mental space where you want him to be if you're a producer. You want to make sure that your level designers are thinking that way. And so Dale was able to use Levelshop to create dozens of floor plans. And at a push of a button, he has a dozen prototypes. And from those prototypes, he can play them in-game, and he can determine if the moment-to-moment layout guides him to the end. Now, so my target is the level designer and empowering them to stay in that zone. So we're going to now go in section 2, which is the markup. So this is a detailed view of the markup language I've got going, and it's hopefully going to give you a picture of whether it maps onto things that you're already doing on paper napkin or grid paper or the whiteboard. So this is the latest view of Inkscape. It's got this toolbar here. I'll just go through it. Select mode, point edit mode, rectangle, circle, freehand, text tool, floor connector, portal connector, roof connector, and wall connector. We're going to start off by drawing some shapes here, a circle and some rectangles. We do a little clipping there. You notice there's a dotted line around these shapes, and that's because I selected them all and hit disable roof because we want to be able to look inside these particular rooms. Now we take the text tool and we just type into the circle 5. And what that means is this room is going to be 5 meters tall. The walls are going to be 5 meters tall. This rectangle here doesn't have any number attached to it. But that's fine because it makes sense for a room to have a default standard height, and that for this standard height for this room is 4 meters. And this symbol here I've stolen from email and Twitter, @. So it's just a notation to tell this particular room that I want a vertical offset. So I'm at 3 meters. So that room will be 3 meters off the ground. But it'll still be 4 meters of wall height for that room. We'll draw some more shapes. You notice some of these have solid lines around them, more dotted lines to disable the roof. This is a dash dot dash line. That's going to say no. That was because I clicked on this button. It's going to add a railing to that particular rectangle. We type in some more numbers. This is -2 here to tell this particular rectangle that you're going to be recessed in the ground. So essentially that will be a swimming pool. And this will be the pool deck. We'll draw some towers here. So by default, standard room height is 4 meters. These towers will be 4 meters tall, and this will be 8. And we use the floor connector. So the floor connector connects floors. So this particular room is at ground zero, and this room is 2 meters off from ground zero. And these floor connectors will create corridors between these two rooms, and they'll ramp up. And they'll ramp up from here to here also. And there's a lot of context-sensitive ways of drawing, too. If I draw a floor connector inside a room, it's going to be a walkway instead of a corridor. And I'll make a compound shape here by taking these A to B walkways and create another A to B walkway, another A to B walkway, and then type in a number at the end. So now what's happening here is in a Lego-like style, I just have a ramp that goes from the floor up 3 meters, this catwalk goes over to 3 meters, and then back down to the circle room. And so I've made this compound shape just by putting these simple shapes together. And we're going to add more walkways, little struts between there, so we can join those two compound shapes. And now we look at the roof connector. So remember we had these towers, 4 meter high, and they have railings around them. So we're going to connect the roof. And the roof connector is a misnomer. It's actually connect to the highest surface. But that's hard to remember. So highest surface connector is not, it doesn't roll off the tongue as well as roof connector. So roof connector it is. So this example here will show you that it's actually connect to the highest surface. And in this roof connector here is going to connect to the floor because there is no ceiling, and it's going to touch to the highest surface on this particular block or room, which is the top of that, which is at 4 meters from that surface. And we put some roof connectors over the swimming pool, so now it's less of a swimming pool, and what it's going to do is connect to the highest surface, which is the lip of the swimming pool. And we're able to also cross these roof connectors and overlap them. And you'll see that there's some nice action that happens over here between the junctions. Now we use this portal connector over here, and we want to be able to go from the swimming pool room to the circle room. So we just connect those two rooms together. And then we'll add some more portal connectors at the front here. And we'll use our text tool, and instead of having them be doors, we're going to offset them with the @2. So they'll be 2 meters off the ground, and they'll become windows. And Levelshop generates this mesh for you. And I'm going to point out a couple things to just show you what Levelshop is doing behind the scenes. So we have a swimming pool here. It's got the railing. You have the roof connector, and it's cleared the railing so you can walk across that surface, and the junctions are cleared up so you can walk all the way around there. Remember, the swimming pool is at ground zero, and this surface is at 2 meters off, so it's going to these floor connectors will ramp from the swimming pool floor to the floor of this particular room. And you notice that those floor connectors automatically create portals so you can walk between the rooms. This walkway went from the ground up to 3 meters, automatically create a portal here, and then you can walk around this catwalk. Those struts automatically clear up that junction area, and then you walk over here at 3 meters, portal automatically created, and you can walk down again. These towers here, that's a 4 meter high tower with a railing, and then it does a roof connect to the 8 meter high tower, and then this does another roof connect to that 7 meter high wall. And you notice I added some lights here. So that's actually markup 201, and you type in the word light and you change the text to green, and then a light shows up. But that might be a bit complicated. I'm being sarcastic there. So the back room here, you'll notice it cuts, it does what you expect it to do, which is cuts a hole in the wall, cuts a hole in the floor, and so you can walk up to the top of that surface.